Well, welcome back. When we finished off last time, we had been learning about solubility and concentration. And we had taken a look at a couple of videos on solubility and concentration in saturated and supersaturated. So what is the amount of a substance that can dissolve in a solvent called, and what are the two things it depends on? It's called solubility. And as we said, the two things it depends on are the nature of the substance and the temperature. So whether or not you're dissolving something like sugar or whether you're dissolving something like salt. So the substance that we're dissolving depends on how much will dissolve and then the temperature. A solution with only a small amount of dissolved solute is called dilute. A solution with a large amount is called concentrated. This is not to be confused with saturated and unsaturated. Okay? When a solution is saturated, no more will dissolve. So at that point, it would also be concentrated. But as it gets closer and closer to saturation, it's becoming more and more concentrated. So we said concentrated is kind of like shades of a color. So, concentrated goes from where it would be diluted, and let's say it was blue, it would be really light blue to very dark blue, and then eventually, the analogy breaks down, but eventually then it just can't hold anymore, and it's saturated. Okay? And unsaturated means that more can still dissolve. Supersaturated is more than normal is dissolved. Okay? A saturated solution is a higher temperature, is cooled, and then when it gets to a lower temperature, it has more than normal. Sometimes it helps to take a look at how this all comes out on the graph. Okay, and we can see on this line, this graph here, they show solubility curves, and usually they graph different substances. So on this one, it has potassium chloride down here, and then this line going across is sodium chloride, and then this line going up like this is potassium nitrate, and this one is sodium nitrate, and this is potassium iodide. All of these are compounds that we worked on in the previous unit. Okay, so these are solubility curves. It's a line graph used to figure out how much solute can dissolve at any temperature on a graph. The graph shows the number of grams of solute that will dissolve to make a solution saturated at any given temperature. So over here on the y-axis, it says solubility in grams per 100 cubic centimeters of water. So it's saying how many grams will dissolve, and then it tells us the amount of water that they're using. Now that's important because the more water you had, the more would dissolve in it. So this, it specifies that we're measuring how much, for example, potassium nitrate can dissolve in water, but it's saying this is the amount of water we used. And then on the x-axis, it shows the temperature. So as we said, as the temperature increases, more and more will dissolve. So along the line, at any given temperature, the solution is saturated. So for example, if we look at this potassium nitrate, at 45 degrees, it would be saturated with 70 grams. So if we had 10 grams, it would be unsaturated, then 20, 30, 40, all the way up to here. And if we put in any more, it would sink to the bottom. So when we had just a little, it would be diluted, and then it would be more and more and more concentrated until it finally got to saturated. The whole time, it would be unsaturated. Okay, so these lines show us exactly the saturation point. How many grams will be saturated? Above the line, no more solute will dissolve because the solution is saturated at that number of grams on the line. Below the line, the solution is unsaturated and more will dissolve. So for example, I highlighted underneath this potassium iodide mixture. So for example, if we look right here, it's 180 grams will dissolve in 30, when the water is 30 degrees, below this line, all this number of grams would dissolve and the solution would be unsaturated, and notice how as the temperature goes up, okay, the amount of grams also goes up, and the point at which is unsaturated goes up. So if we had a saturated solution here at 30 degrees, and we raised it up to 70 degrees, okay, it would be unsaturated at 70 degrees. Okay? And then the same thing goes with this potassium nitrate. Right along the line, at any given temperature, it's saturated. Below this line is, at any given temperature, is where it's unsaturated. Okay? Now, remember that when we mix a gas in a liquid, it's the exact opposite conditions as mixing a solid into a liquid. Okay? So when we mix a solid in a liquid, the warmer it gets, the more it dissolves. With a gas, the warmer it gets, the less dissolves. So the solubility of a gas decreases as the temperature increases. And we looked at that guy with the sodas that exploded when they were warm. So it's a good example of a gas didn't want to stay dissolved when it was warm. So the curve for a gas will always be going down, not up. Now this is important because sometimes on the test for the SOL, they'll give you one of these graphs and say which one of these substances is a gas, okay? And you know, if you're the typical 8th grader, you're going to be looking at this going, well, I don't know what any of these substances are. I've never seen potassium iodide or potassium nitrate or sodium nitrate. Maybe you've seen sodium chloride, that's salt. Probably not potassium chloride either. And so you're like, well, I don't know what these things are. I don't know which one's a gas. Well, you're going to know which one's a gas because it's the one where the line is going down. Okay, so the gas will go down. To make a supersaturated solution, we saturate it at a high temperature. So let's say we had this potassium nitrate. We got it saturated at 90 degrees. At 90 degrees, 200 grams would be dissolved. And then, if we cool it down, we cooled the solution down to room temperature, which is about 25 degrees Celsius, only 40 grams should be dissolved. And this is what the girl did on the video that we watched last time. Okay, at the high temperature, she had the substance was saturated up here, so it had a lot of grams in it. And when she cooled it down, okay, the large amount of grams, like in this example, 200 grams, stayed dissolved, but they didn't really want to be there. Okay, you kind of tricked it by heating it up and getting it to dissolve at this high temperature. So when you cooled it down without disturbing it, that stuff would have settled to the bottom, and that's why it wanted to crystallize when she stuck her finger in it. So at 25 degrees, only 40 grams is saturated. So the extra 160 grams is the supersaturated part. And that's the part when she stuck her finger in the water that crystallized, okay? Because it really would have wanted to have sunk to the bottom, but by tricking it and getting it to dissolve at this higher temperature, it was in there, but it was ready to become undissolved and turn back into crystals. Okay, now I want to pause here for a couple of minutes, just pause the video, and I want you to try and answer these questions on your own, and then restart the video, and we'll go over the answers. Okay. All right, so the first question says, how many grams of sodium nitrate will dissolve at 45 degrees? The first thing we want to do is find the line they're talking about. The line they're talking about is this one, is the sodium nitrate. And then it says 45 degrees. So we're going to find 45 degrees on the x-axis, and we're going to go up to the line, and we go over to the y-axis, and it tells us 110 grams would dissolve. Question 2 says, which solid is most soluble at 5 degrees? So the first thing we want to do is find 5 degrees. 5 degrees is right here, and put this blue line. So it says, which solid is most soluble at 5 degrees? Well, it's not the potassium chloride down here, only a little dissolves, and the potassium nitrate more dissolves. More sodium chloride dissolves, the sodium nitrate more dissolves. The one that dissolves the most is the potassium iodide. It says which one is least soluble at 5 degrees. The one that would be least soluble is down here at the bottom. It would be the potassium chlorate. And it says for all the solids, how does increasing the temperature affect the amount of solute to dissolve? Well, as the temperature goes up, so do the number of grams. So solubility increases as temperature increases, and we said this is pretty typical. The warmer something is, the more stuff will dissolve in it. If you add 130 grams of potassium nitrate to water at 60 degrees, would it all dissolve? The first thing we do is find the substance they're talking about, and I highlighted it here with that purple line. This is the potassium nitrate right along this line. And then they said the water is 60 degrees. So we're going to locate 60 degrees here. And put this light green line here at 60 degrees. And it says if we added 130 grams, so here's where 130 grams is, and where 60 degrees and 130 grams meet is here at this point. That is above the line. It's above the point where it's saturated. We said it would be saturated right here along this line at any given temperature. So potassium nitrate is saturated when it has 110 grams at 60 degrees. So this is the point of saturation right here. So if we said no, how much would not dissolve? Well, only 110 grams can dissolve, and we dumped 130 grams in there. So the difference is 20 grams. Okay, this is what would settle to the bottom, like when that kid was mixing in the sugar. Okay, some of the sugar stayed to the bottom and it would not dissolve. And if you measured it, okay, like we did in this case, it would be 20 grams of the substance. Now, particles in solution. Part of this should be a review from what we did earlier in the year. Okay, we already know that ions are particles with charge. Electrolytes are compounds that are formed by charged particles or ions and conduct electricity. So, like if you play sports, you know the Gatorade contains electrolytes. So they're dissolved salts that help your body conduct electricity. Electric impulses go from your brain to your muscles, and it's what allows you to move around. It's why it helps you not get cramps. Non-electrolytes are substances that don't ionize the water and conduct electricity. So these would be ionic compounds, and these would be more covalent compounds probably that are dissolving. Things like sugar is not an electrolyte. Okay, how do the ions form? How do things do? It's the process of ionization. And molecules break apart in the water, causing atoms to become ions and take on a charge. Now, in the beginning of this unit, we looked at that little video of the salt crystal dissolving, and we remember how the water molecules, the negative ends of the water surrounded the positive ends of an ion, and the negative ends of polar water were attracted to the positive ions. So here's what was going on. We had the salt crystal here. The chlorine is negative, and the white is sodium, which is positive. And then it shows that the water molecules are clumping around here, and the blue positive ends are attracted to the negative sodiums. And then it shows around the sodium ions down here, the white one, the negative oxygen, the red end is attracted to the sodium. So the positive and negatives cancel out, and they float away. And this is the part where it's become completely ionized over here and dissolved. Okay. Dissociation is when an ionic solid separates into its positive and negative ions. So this is what's happened over here. Okay, the particle is disassociated. They were associated when it was a crystal, and now they're unassociated or disassociated when they've broken apart and dissolved. Okay. All solute particles, whether polar, nonpolar, electrolyte, non-electrolyte, affect the properties of the solvent. So, for example, obviously when the salt dissolved, one of the properties that affected was the taste of the water. The water didn't taste salty. Okay. Adding a solute to a solvent lowers the freezing point because the added solute particles interfere with the formation of crystals. So when you salt water freezes at a temperature below regular pure water. So this is why, like, if you've seen the movie The Titanic, when the people jumped in the water, they froze to death so quickly because water normally freezes at 0 degrees. So think about, like, if you filled the bathtub with ice cubes, it would be at 0 degrees. You know, when you mix water and you just have this ice water. Imagine how cold it would be if you got in there. It'd be really cold. And if it was salt water, if you mix salt in there, the temperature is going to go down even lower. Okay? It might be another 15 degrees colder below freezing. So instead of water being at 0 degrees Celsius, it might be at negative 15 or negative 20. And it's still liquid because the freezing point of the water is lower. So when people got into the ocean water, which is salty, around the Titanic, it was colder than the normal freezing point. So that's why they froze to death so quickly. It's also why we add radiator fluid to the water in a car's radiator so that it stays liquid at lower temperatures when it's freezing outside. So we know that water expands when it freezes, and of course if it was inside the engine and it expanded, it would cause the engine block to crack. So people put radiator fluid in there so that it doesn't freeze when it gets cold, and like where we live in Virginia, and break their engines. Okay? It also raises the boiling point. Okay? These water molecules have a harder time breaking loose and turning into a gas because they're attached to these sodium and chlorine ions. So I put us a little graph here, okay? And I show water without a solute, regular pure water. The freezing point is 0 and the boiling point is 100. When we add a solute, salt, sugar, radiator fluid, whatever, we put it in with the water. The new boiling point is higher and the freezing point is lower. So, for example, when it snows pure water. So the freezing point of the snow is 0. So you go out and it's solid. It's frozen water on the sidewalk and on the roads. When they add the salt to it, it lowers the freezing point. So it becomes a liquid again. The new freezing point is maybe negative 20. So it's not cold enough outside to freeze salt water. So by adding the salt to the roads and to the sidewalk, the road salt, that's why it turns back into a liquid, and then the ice can drain off the road or off the sidewalk, and we can walk on it. The same thing is when people put radiator fluid in, like I said, in the car. Okay, instead of the water freezing at the freezing point of water, but it's 0 outside, which is pretty common, and it would crack your engine block. By putting that in there, it lowers the freezing point, so you don't need to worry about your engine, water inside the engine freezing on really cold days. It also raises up the boiling point so that it doesn't turn into steam inside the engine either, okay, and have a lot of pressure. Okay, so I said, think about what a radiator fluid does for a car. It lowers the freezing point, raises the boiling point. This also happens when people put salt in water when they're cooking. It raises the boiling point of the water, so it cooks the food a little bit hotter than it would if they were cooking in pure water. Okay, so here we have pure water. It freezes, and it shows it's easily making these ice crystals. We see that when it's got something like salt mixed in it, okay, the water molecules are attracted to these ions because they're polar, and they can't get into these positions to make crystals as easily because it interferes with their ability to make crystals because they're attached. Okay, now I want you guys to answer these questions on your own, and we'll pick up here when we come back next time. I hope you have a great day, and we'll see you soon.